Welcome, everyone, to today's Explainer. We're going to completely dismantle a myth today that an outdated, monolithic climate collapse destroyed the great Indus Valley Civilization. I'm going to walk you through the latest archaeological data to show you that ancient populations didn't just helplessly succumb to the weather. No, they adapted. Let's just dive right into this grand historical mystery. Picture this, around 1900 BCE, a civilization literally larger than both Egypt and Mesopotamia combined just seemingly abandoned its massive, highly organized urban centers. For decades, the burning question has been, well, why? Okay, here is our syllabus for today's lecture. We'll be covering the Indus climate mystery, flawed models versus local data, hydrology and settlement choices, urban nodes and the Indus script, rural resilience and crop diversity, and finally, transformation rather than collapse. All right, let's jump into Section 1, the Indus Climate Mystery, Beyond the Riverbanks. To really grasp this mystery, we've got to understand the sheer scale of the Indus environment. Unlike the highly centralized single river systems we see in Mesopotamia and Egypt, the Indus civilization stretched across over 1 million square kilometers. And it was packed with incredibly diverse ecological zones. Their settlements occupied this really unique environmental threshold, where steep winter and summer rainfall gradients actually overlapped. Moving right along to Section 2, flawed models versus local data changing the paradigm. For the longest time, historians leaned heavily on a genuinely flawed hypothesis to explain why these cities emptied out. These old top-down models relied on distant climate proxies, taking samples from places as far away as Oman, to declare that a sudden global drought just wiped the Indus people off the map. It's kind of like checking the weather in London to see if you need an umbrella in Rome, right? But now, bottom-up local archaeological data is telling us a completely different story. It's a story of brilliant, deliberate adaptation to a changing landscape. And to truly uncover this adaptation, modern researchers absolutely have to use an integrated, multidisciplinary approach. We can't just look at the pottery anymore. We have to reconstruct these ancient socio-ecological systems literally from the dirt up, combining geology, hydrology, and archaeobotany to figure out exactly what these ancient farmers were dealing with. This kind of work requires intensive groundwork. Archaeologists are out there digging into local trenches to pull up the empirical evidence that directly challenges those outdated, distant collapse models. It's this precise, localized field data that proves just how resilient these communities actually were. That brings us to Section 3, hydrology and settlement choices, water management. So how exactly did local hydrology dictate where they lived? When we map out the Indus territory, we find this fascinating environmental sweet spot, a threshold where those steep winter and summer rainfall gradients overlap. This seasonal water overlap was basically the lifeblood of their early agricultural resilience. It meant that if one seasonal rain system faltered, the other one might just swoop in and provide. And because their rainfall was incredibly variable from year to year, they developed a really specific mindset. Experts call it predictable unpredictability. Essentially, they baked risk mitigation directly into their culture in their everyday survival strategies. This meant their urban centers utilized highly specific, localized environmental strategies. For example, Mohenjo-daro tapped into deep groundwater wells. Dhalavira, which sat in a much drier zone, engineered these massive, stone-lined reservoirs and dams. And Rocky Gari? Well, the latest data actually reveals it wasn't even situated on a perennial glacier-fed river at all. It thrived as a major city by brilliantly capturing ephemeral, muddy monsoon runoff. Okay, moving to Section 4, urban nodes and the Indus script, a decentralized network. Now here's a great question for you to ponder. How did a civilization spread so sparsely across such vast, unpredictable landscapes actually stay connected? Current evidence points away from a top-down dominating empire and more toward a heterarchy. These cities functioned as independent, sparsely distributed nodes. They likely utilized standardized weights and that famous, mysterious Indus script to maintain socio-economic control and fluid trade across distinct hinterlands. So it was cooperation, not necessarily a ruling elite class, that bound them together. Next up is Section 5, rural resilience and crop diversity, surviving the shift. But what happens when the climate does eventually, inevitably, shift? Around 2100 BCE, as the monsoons started to weaken, Their massive geographical footprint proved to be their absolute salvation. Their settlements were spread across entirely different climate zones. We're talking everything from arid deserts to temperate regions. This diverse local ecological regime essentially demanded highly adaptive survival behaviors from those rural communities. And because of this incredible diversity, local rural communities perfectly tailored their subsistence strategies. They didn't just put all their eggs in one basket by relying on a single crop. Nope, they mixed winter crops, like wheat and barley, with summer crops, like millet and rice. This interplay between winter and summer rainfall created this unique agricultural resilience. By multi-cropping, these ancient farmers leveraged unpredictable moisture to maintain stable food supplies, which acted as a fantastic buffer against unpredictable seasonal rainfall. Which brings us to our final section, transformation rather than collapse, a paradigm shift. And here is the profound conclusion of our lecture today. We have to dismantle the myth of the Great Collapse. The Indus civilization didn't just vanish because the weather got a little dry. They didn't fall to a single devastating drought. Instead, they recognized their shifting environmental thresholds, and they deliberately decentralized. As those massive urban centers became unsustainable under prolonged climate stress, the population actively embraced a rural lifeway. Post-urban archaeological data clearly shows these settlements dispersing into smaller village-sized networks across regions like Gujarat and Haryana. They essentially utilized diverse ecological niches to maintain their long-term stability. As our source material so beautifully puts it, populations adapt, adjust, move, die out, or thrive, depending on their circumstances. The people of the Indus found sustainability not by stubbornly fighting their changing local environments, but by adapting to them. Their masterful rural resilience ensured that their cultural legacy survived the emptying of their grand cities. I want to leave you with this final thought for today's class. As we face our own modern global climate shifts and increasingly urgent water crises, what can we actually learn from the magnificent local resilience of the Indus Valley? How might we apply their absolute mastery of predictable unpredictability to our own uncertain future? Thank you so much for joining me on this deep dive into the resilient reality of the Indus civilization.